Pulleys 5. This video covers a 3-mass pulley problem. You can see this in the picture below. So example 5, 3 masses A, B and C are connected. Mass B rests on a smooth horizontal surface and is connected by one string to C and another string to A. The inextensible strings connecting each of A and B and C pass over smooth pulleys. A and C hang vertically. The masses A, B and C are 2 kilograms, 7 kilograms and 5 kilograms respectively. See the diagram below. And the first question is to calculate the acceleration of the system. Well, before doing that, again, go through the 4 steps relating to any pulley problem. The first step is done because a picture is provided. The second step is to add the forces. So there is a tension here, T1. A has a mass of 2 kilograms, so it has a weight acting on it of 2G. B has tension 1 acting on it to the left. It has tension 2 acting on it to the right. It does have weight and a reaction force, but those don't contribute to its left and right movement, so we can actually get away with ignoring those in this problem. C has a mass of 5 kilograms, so it has a weight of 5G acting on it, and it has a tension T2. In this problem, because there are 2 separate strings, it's possible that the tensions are different in different strings, and therefore we can't just label all of the tensions T. They have to be T2 on one string and T1 on another string. That's step 2. Then we should also put on the acceleration arrows. It makes sense to think that the system is going to move in such a way as to have C drop and A rise, because C is heavier than A. So the acceleration will be directed down for C, to the right for B, and up for A. That's step 3. Step 4 is to apply F equals ma to each object in the system. So F equals ma. If we apply this to object A, resolving upwards, so we'll have T1 minus 2G equals 2A. If we then apply F equals ma to object B, which is travelling to the right, so T2 minus T1 because it acts to the left in opposition to our positive rightward direction, 7A ma. We apply the same to C. C goes down, but it accelerates down, so we make down positive. 5G minus T2 equals 5A. Between these 3 equations there are 3 unknowns. The 3 unknowns are A, T1 and T2. So with 3 equations it is possible to find 3 unknowns. Just requires some organization. If equations A and B are added to each other, we can get rid of T1. Just saying we're bringing them together by addition. So that would be T2 minus 2G is equal to 9A. We also have the other equation, 5G minus T2 equals 5A. Now, just looking here, ignoring everything else, we have 2 equations with 2 unknowns, T2 and A, so it's possible to solve for those 2 variables. Again, use elimination, so 3G is equal to 14A, therefore A is 3G over 14. Calculate A, that's 2.1 meters per second squared. And then part B of the question, calculate the tensions in the strings. So that would be calculate T1 and T2. Well, as we know acceleration, if we use equation A, that being T1 minus 2G equals 2A, we can find T1. And calculate. That's 23.8 newtons. And then I need to get to T2. That can be calculated by using equation C. So 5g minus T2 is 5a. Therefore 5g minus 5a is T2. Again, acceleration is 2.1. That can be seen above. There's T2. And calculate. T2 is 38.5 newtons. And that's the answer to that question.